Who's Yellow was designed to determine if the proportion of yellow M&Ms and Skittles are the same. We were responsible for doing a significance test for yellow Skittles, calculating the proportion, and then computing a 95% confidence interval for the samples. We then compared this to the corresponding sample of yellow M&Ms and found the difference of the proportions. We concluded that we do not have enough to reject the null hypothesis.
In the project that we did, we had to go through certain conditions. So the first thing we want to do is figure out what our values are right now. So for the M&Ms right here, we have our p hat, which is going to be 0.3. And we're going to find that because in each sample, we found 10 M&Ms right here. And in this particular sample, our x value was 3. So when we take 3 divided by 10, we find 0.3. So that's our p hat 1. For the Skittles, we are marking that as the second value. We used 10 Skittles, same numbers in the M&Ms, and our x value also came out as 3. So our p hat stayed the same value. So for this test, we used a 2-prop z-test because there's two proportions and we're trying to find the difference of them. And the sample was random and independent, assuming that we grabbed a random bag of M&Ms and Skittles, and we know that we chose Skittles randomly from the bag, not by looking in there or anything. So what we want to do first is make sure that when we multiply our p hat by our n, that we get a value that's over 5. So when we do that for the Skittles, we get 0.3 times 10 equals 3. And when we do the same thing for the Skittles, since our numbers are exactly the same, we get 0.3 times 10 equals 3. So our sample size is too small, but we're going to proceed anyways. The next condition that we have to go through is we have to take 1 minus p hat times our n value. So we're going to have 1 minus 0.3 times 10 equals 7, which is greater than 5, which is good for the M&Ms. And our values were exactly the same for the Skittles, in which we had 1 minus 0.3, which is 0.7 times 10 equals 7. So those conditions were met. And then to make sure that our population was not greater than 1/10 of the true population, we multiplied our n value by 10, which equals 100, and we know that there are more than 100 M&Ms on Earth. Then we have 10 times 10 for the Skittles, and that gets us to 100, and we know there's more than 100 Skittles on Earth right now. So that's definitely met. So next we have our hypotheses, and our null hypothesis is that the true proportion of yellow candies and M&Ms and Skittles is equal. That's what we think to be true, and that's what we're testing, is to see if we can disprove that. And our alternative hypothesis is that the true proportion of yellow M&Ms is not equal to the true proportion of yellow Skittles. So there's a significant difference.
There are two mathematical ideas we can use as evidence for or against our null hypothesis. First, finding a test statistic for the difference of two proportions using the shown formula can tell us whether or not to reject our null hypothesis. In this case, our critical values are negative 1.96 and positive 1.96, and our test statistic is 0. As shown in this graph, this test statistic falls in the non-rejection region. Therefore, we should not reject the null hypothesis. We can also use the idea of a p-value, or the probability that our sample will occur given that the null hypothesis is true. In this case, our significance level is 0.05 and our p-value is 0.99. Since our p-value is greater than the significance level, our sample is not rare. In fact, it is a reasonably likely sample given that the null hypothesis is true.
Looking at the data that our group has come up with, we have come to the conclusion that we do not have enough evidence to reject the null hypothesis that the true proportion of yellow candies in both M&Ms and Skittles is equal. With a 95% confidence interval, we would have a critical value of negative 1.96 and 1.96. So our test statistic would have to fall within the range of that curve. We came up with a test statistic of 0. This means that our sample falls right in the very middle of the normal curve in the non-rejection range, and well within the critical values given. Using this information, we do not have enough evidence to reject the null hypothesis. So now we can rest easy and know that yellow M&Ms and yellow Skittles are equal in this world.